sponge, Rosie.
Max only hit one.
Hey,
for
I
last
made
night.
them over the weekend. I made them on Sunday.
I love it. It's good. It's just old. Really old. Is this things we're mad about? Things we're
Sad
sad
about.
about.
I only went 115 last night. Wow. Why is it so like burnt in here? Were you feasting us or
How are you?
Max went 2 for 2 with shot on the other end.
Max was not 2 for 2.
He was 1 for 1, and then he missed again.
Whoever put that.
Someone really. What?
I got
Someone
stuff
did
for you.
put the
Oh, wait, not
Holocaust.
this.
Yep.
Uh-oh. Oh, here it is.
Okay.
Dude,
What?
chill!
Right.
I'm literally trying to write. He went 1 for 1.
Like, no, it smells like burnt.
It does, because I made
Look
burnt
at how
popcorn.
perfect that slant was.
Michaela Miller gave me popcorn for Christmas. I decided to eat it. Turns out it burns really easily. So it's hot on fire. All right, sit down. I'm starting now. We barely will have enough time to get through all this. We probably won't. The only class to get through all of it was first hour. Here we go.
Here's your starting lineups.
I'm going to start whether you're sitting down or not.
Here's your starting lineups.
Chill.
Metaphor number 54.
Sorry. What? Said he's not here again.
I know.
Metaphor number 23. It's the big tall
Who put the Holocaust?
Dude.
This board has gone from just the
You're like a
board
whole
of
last
talking
paragraph
about
on
your
there.
experience.
What about
Basic, really.
That's
to
something we're
like
sad about, is it not?
Who else needs a review guide?
Me!
Oh, wait, what are you sad about?
Wait, actually, I'm probably not gonna write on it. I'm just gonna look at the board. Don't give it to me,
Great.
please.
Nope, take it anyway.
Ah!
You can try it at home on your own. All right, starting now. Basic. Go.
What?
Review guide. All right, I'm starting.
What?
Amy needs a review guide.
Who does?
This question.
God.
She tried
I
saying
can't believe you.
basic white
All
chick.
things I'm sad about. I can write down.
Call me that.
Pardon me?
There we go.
Gotta rate Chelsea
Oh.
again. I'm
Chelsea,
sad
yeah,
about
Chelsea makes me sad too.
Who put Kobe equals dead?
You need to highlight
Hey,
it.
I put Legends Never Die, okay?
You're so funny. You make fun of Kobe. Dead. Thank you.
This is things we're sad about.
Someone circled Chelsea yesterday.
That was
I know
me.
All right, I'm going.
Who put my name
black.
down? Matt, who put my name down?
I don't know. I don't read.
Did you really only go 115 last night?
Huh?
It says you went 115 last night.
I mean, like, say it.
Above
Where
me.
it's highlighted. It's
There it is.
there.
Review guide. Let's go.
That wasn't me.
Yep.
This sucks.
All right, A, B, and D, E are parallel. So that means this.
I know Mr. Robbins brought the popcorn truck back over here. He has a popcorn cart upstairs.
We're going to prove these two triangles similar. Which two triangles? Triangle ABC and triangle DEC. Now, we do have a shared angle. Now, you're going to see a lot of vertical angles, shared angles, and all kinds of stuff. Go. Yes, all kinds of stuff tomorrow. Not everything will be useful. Shared angle will be in this case because it pertains to both the triangle here, which we care about, DEC, and the triangle here, ABC, right? So that will be useful. What?
Do we know if they have two sides that are the same?
Nope, we don't.
Okay.
So by shared angle, angle C is congruent for both. Now remember, to prove similarity, we have three ways of doing it. Double angle, right? Angle, angle, similarity. Side angle similarity. Side angle side, right? And then triple side. So side angle side is when we have two sides that are proportional with an angle in between. So for instance, if I have a triangle like this, that's not enough information to prove that the triangles are similar, right? Alicia, for you. Help yourself. Great. So, these two are not similar because we only have two sides and we need three sides to get it done. But note that they do relate. 3 relates to 6 the same way the way 4 relates to 8 by half, right? Or double, depending on how you look at it. If we had an angle in between here for both these triangles, then we would be able to use side, angle, side. Notice that they're not congruent sides, but proportional. If I had triangles like this, and let's do 12. 3 times 2 is 6. But 4 times 2 is not 12, right? So they would not be proportional sides. So these would not be proportional. Even if I had something like this. 2 of the sides are related by double, right? But 1 of the sides isn't. Not enough to get it done. You need 3 sides to all be proportional for it to be side, side, side. So we've got 1 angle. If we can get another one, we win. What do you see?
Corresponding.
If we have 2 parallel lines, you should be looking for corresponding angles. Remember, 2 parallel lines with a line cutting them, that's a transversal, right? Any line that cuts 2 others is a transversal. If the lines are parallel, then the angles, corresponding angles, will be congruent. We have 2 parallel lines cut by a transversal, right? So these 2 angles should be the same because they're corresponding, right? Top right of the intersection, right?
That makes way more sense. I was looking at C and A.
Yep. Now we can also say the same thing for these 2 angles because we have a transversal cutting 2 parallels, and they would be a different color because they would be congruent to themselves, right? But not across the way. But we already have 2 angles, so we'll call it a day, right? Small triangle has a blue angle and an orange angle. The large triangle has a blue angle and an orange angle in it, right? Large triangles, these 3 angles. And so we have double angle. So by angle similarity, the big triangle, we'll call ABC, is going to be similar to the triangle on top. Now notice that the big triangle has a blue angle, an unknown angle, and an orange angle. What's the blue angle in the small triangle?
B.
So A and D are going to go together. B is the unknown angle in the big triangle. What's the unknown angle in the small? E as in elephant. And then C is shared, right? They both use that orange angle, right? So C goes with itself, yep. Everybody good with that?
Okay, this one makes sense to me.
Awesome. Yeah, this is the day everyone's going to get stuff, which is almost exactly 2 weeks ago, right, when I told you that it would take 2 weeks to learn this.
Why don't we
I
put
thought you said it would take 3.
No,
I can't hear. Shut up.
Why don't we put corresponding angles?
Ooh, good point. We didn't write that. Before we do that, we have to write by cap angle CDE was congruent to angle CAB.
Why?
Well, that's how we got those 2. And now that we have them, then we could do AA, right? Before all we had was this orange angle, right?
That'd be skipping a step.
Right, we need another angle. So there's our other pair of angles. Now we have 2 pairs of angles, an orange and a blue, an orange and a blue.
Yeah, no.
Right, okay. So we can say they're similar. And if they're similar, we can say other things through CSP, but we don't need to. Right, we're done.
By blue, black is true.
Yeah, pretty much. How do you feel?
I like
I
that.
think that's gonna be the easiest one. So is the goal just to prove that they both have 2 angles?
If they're both similar. If you can get 2 angles, that's one way to prove they're similar. You can also do it with sides, but we didn't have any information about sides, so we couldn't. Yeah.
Can you like up there?
So first we said that, Schlaffer, first we said that this triangle shares angle C with the whole triangle, right? See how they perfectly overlap? They both share that angle, right? These angles are both congruent, but they're not shared, right? Shared means there's an overlap. They both use it. So those angles are congruent. Then by cap, because those 2 lines are parallel, these are corresponding, so they should be congruent, right? So those go together. We could say the same thing over here. If you wanted, you could have gotten these ones instead. Or you could have gotten both. But we only need 2 angles to get it done, right? A blue and a blue is one pair, and an orange is the other pair. So we have 2 angles, right? And then we could say they're similar. Cool. All right, next one, 2. All this says is that BD is a line segment, so your eyes do not deceive you. That is a straight line. There is no bend there at C. That means this angle and this angle will be a linear pair. AE is a straight line, which again means this angle and that angle will be a linear pair. There's no bend at C. Now remember, just because you see a linear pair, just because you see vertical angles, just because you see a shared angle doesn't mean you should write it down.
Bless you.
Because if you write it down, it's going to clog up your diagram. You should think to yourself, will this actually help me accomplish my goal, right? So yeah, these 2 are a linear pair, but why do I care about this angle? It has nothing to do with the 2 triangles I'm
Those are
interested
the
in,
other angles.
right? So, B and E are congruent, we're given that.
That is very helpful, actually.
Yes, it is, otherwise it would be impossible. So what do we want to do? We want to prove that there's a relationship between AB and BC and CE and DE. So which 2 triangles do I care about? These 2, right? Now again, it's pretty obvious. I only have 2 triangles in this diagram. But when we get later on into Triangle City, right, it'd be good to identify what you need. So these are the 2 I'm interested in. I have angles already. I have no information about sides, so we're not going to be able to do side, angle, side, or side, 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 right? We got to do angle, angle. And you're right, there are vertical angles here and here. Now, these are also vertical, right? But I don't care about them because they're not part of my triangles, right? So I'm going to get these two. By vertical angle theorem. Angle, can't call it angle C because there's multiple angle C's, right? There's actually 4 different ones. I'm going to call it BCA. You could call it ACB as well, right? And then ECD. You could also call it DCE. Doesn't matter.
Why can't you just say angle C again?
See how there's multiple angle C's,
Yeah.
right? Here, there's only one angle B and one angle E.
Yeah.
But there's multiple angle C's. So we have to call it by its full name. It's like when you have a student that has the same name with another student. You use the full name.
Tommy D.
What? Diagonal.
Oh, sorry. So that's where you're done, correct? Because
Not yet.
angle, angle.
We're going to do angle, angle. We're not done yet. We got plenty more to do. Yeah. That will be the next step. So, vertical angles theorem is what that means. Whenever you have an x, these angles and these angles will always be congruent. Right? That's scissor theorem. Right? Notice that if I have an x, the top and bottom are always the same. Left and right are always the same. Even if I change that x, no matter what I do, sides will be the same and top and bottom will be the same. So because that's an x, those are two straight lines intersecting, we have vertical angles. No, it's okay. So now that's how we got it. Now, we can say by angle, angle similarity, the two triangles are similar. I'm going to start with the left side triangle and do ABC. Similar to the right side triangle. Now I got to match up letters. Notice that A is the unknown side, right? So we know that all these have to add up to 180, right? So 180 minus the green minus the blue is this angle, right? Whatever's left over. Isn't this angle also 180 minus green minus blue? What's left over? So they must go together. In fact, they will be congruent. So A and D go together. So I write D next. Yes?
I didn't really
B is the green angle, so it's going to go with E. And C is the blue angle, so it's going to go with C in the other triangle, right? Cool. So those guys go together in that order. Could you have written CBA over here or BAC? Sure. And then you would have mixed up your letters over here too. Cool. That's right, it's different. We're changing things a little bit. All right, so these two triangles are similar. Once the triangles are similar, you can use CSP to do stuff with the letters, right? You have to prove that they're similar first, which we just did, right? But now you can use CSP. It's kind of like CCP, but for similar triangles, right? By CSP, corresponding similar parts is what that stands for. The parts that are corresponding will be similar. So corresponding means same relative location, right? Kind of like we were talking about with corresponding angles, right? They're in the same relative spot. So the letters that correspond will go together. So notice that AB is first and second here. What's first and second over here? So they're going to relate. And remember, we show relationship by division. They're not congruent, they're just related. Maybe they're half, maybe they're quadruple, maybe they're a quarter, I don't know. BC on the first triangle will go with what on the second triangle? EC. E is an elephant, right? And then everybody forgets about first and third. AC is going to go with DC. Yep. Now, I don't care about all of those sides. What I care about is AB and BC and CE, which is just EC backwards. That's okay. And then DE. So I don't really care about this guy. That's fine. All of that was true. But I only care about these ones, right? So how do I get division into multiplication? Right? What do I do?
Is it okay if you don't put the last one then?
That's fine, yeah.
Okay.
You don't need it. So what we're going to do is this. I'm going to look at the ones that I'm interested in. You don't have to write this. I'm going to rewrite it. I'm going to rewrite it with CE because that's what they had at the top, right? Oh, yeah, and by the way, I made a mistake. Sorry. Change that BC to the top to a CE. And change that CE over here to a BC. Sorry, I was going to change it between second period, but I forgot, and then I printed 50 of these, so oops. Right? You're not allowed to change that on your test. You can't just make it whatever you want. But I made a mistake. Guys, spoilers. This is the same thing we've been doing the last 2 weeks. Literally the same packet. I just changed some of the letters. But some of you guys are going to be like, review packet was so much easier. Right. So here we are, right? That's the ones we're interested in. So what am I going to do to move stuff around? You don't have to show all this work, but I'm going to show you why it's true. To get rid of divides by CE and move it over, right? What I'm going to do is what? multiply by CE to both sides. Remember, if you do it to one side, it's child abuse. If you do it to both sides, it's algebra. Right? So, check it out. When I do it to both sides, why does it go away? Why do things cancel? Here's what's really going on. This is a fraction. That means division. BC divided by CE, right? And that's times CE. Well, you can do division and multiplication in any order you want. And this is a lie. So what if I, instead of dividing BC by CE, I did CE divided by CE? What's CE divided by CE? 1. And then I have to multiply by the top, right? Multiplication happens at the top. What's 1 times BC? BC. So it goes away because it becomes 1. And 1 times BC is BC. Again, I wish I had you guys for algebra. Algebra can be really easy once you learn why things do what they do.
Last year, just I said that was easy.
Yep, and then you don't actually know it and you're screwed later, right? So here we are.
Summer school.
Is this going to go away, become 1? No, because CE divided by DE is going to be some number, right? So multiplication happens at the top, division happens at the bottom. We're multiplying, right? So C is going to go on the top or the bottom? The top. Yep, and just divide later. Multiplication happens in the top. Now, we want to move that DE over, right, to be with BC. So how do I get rid of divides by DE? Both sides by DE. Do you need to show all this work? No, but I'm showing you why. DE divided by DE is 1, right? And 1 times whatever's left over, right, will be what's left over.
So could this kind of be represented almost as substitution?
Sort of. Really, this is just doing algebra. Do we do multiplication property, right? Remember that? We had that really early in the semester. But eventually, I don't want you to write me a book. We're going to assume we know things, right? So here we have. Now, notice that they wanted AC then CE on the left, and we have CE then AB, right?
Switch it.
So we got to switch them. How do we know it's okay to switch them?
Multiplication.
It's multiplication. 2 times 3 is the same thing as 3 times 2. That's commutative property. You don't need to write it, but you can. These things can switch. And now we're done.
Can you go back up to
Oh, yeah.
CCPs, or I don't get it?
All right, so we got the triangle similar by double A, right?
Yeah.
Then we're allowed to use CSP. CSP says if the triangles are similar, their parts should be related. So similar triangles have congruent angles, right? And they have proportional sides. We show proportions by ratio, division. So AB and DE should relate. BC and EC should relate. AC is first and third, right? So it's going to relate with DC first and third. Cool? Now, I only care about these ones because those are the letters I care about. AC and DC aren't up here. So I ignored that. I just took these guys. I times by C to move it over, times by DE to move it over. That's it. Better?
Yeah.
How do we feel? Gold? Dan, are you with me?
In order for it to be done, do they have to be in the order that they want it to be?
Yeah, otherwise minus a half. Sorry. If that's the only thing you miss, if you do a retake, I'll give you that point back to you for free, right? But yeah, I gotta have them in the same order. All right, here we go. Number 3. Alrighty. They say that angle C and angle DEA are the same angle, and not only that, but they're equal to 90, right? So angle C is 90. Angle DEA is 90. Right?
Yeah.
Now, if DEA is 90, what's DEB?
90.
Also 90, because linear pair, they have to add up to 180. So if one of them is 90, the other has to be 90 as well to add up to 180. So you get these for free. You don't have to say by linear pair. Last year we would have done that, last semester, but now you just get it for free. So that was all this. Yep, they're supplementary. That's what linear pair means, right? So here's what we want. We want to say that AD and BC are related somehow. AD and BC and AB, the whole thing down here, and DE. Now, luckily, there's only 2 triangles, so those are the 2 triangles I want to get similar, right? This one and that one. And I'm going to be able to because, look, this triangle's a right triangle, this big guy, and this one's a right triangle. So the odds of them being similar, pretty good. Now, do I know anything about the sides? No, so we're not going to use SAS, we're not going to use SSS, so we need double angle. Where am I going to get my last angle?
Shared
A. See how the small triangle uses all of angle A?
No.
Right? See how the small triangle uses angle A?
Yeah.
See how the big triangle uses A, B, and C, so it also uses angle A. Now notice the small triangle does not share angle D with the big triangle. So angle D is not part of the big triangle. The big triangle is ABC, right? They don't share E either. Because E is part of this triangle, but it's not part of the big triangle, right? Now, those angles are congruent, but they're not shared. You see the difference? A is the overlap. This guy, A is overlapped with this guy. So we say by shared angle.
Do we need to put linear there here for the other?
You don't have to. We're going to give that to you as given, right? We didn't do multiplication property on the last problem.
Angle A is
By shared angle, angle A is congruent to angle A. So that's saying that both triangles have that angle. Now they already gave us the other angle, so we don't need to talk about them. But look, this triangle has a right angle and an orange angle. The big triangle, again, ignore this. The big triangle has a right angle and an orange angle.
and CSP.
So by AA, they're similar. We can't use CSP until we prove them similar. Yep. So by double angle similarity, right? Let's do the small, actually let's do the big triangle first, ABC. Big triangle's ABC, right? Now let's match up the parts. On the big triangle, angle A is orange. What's the orange angle on the small triangle? A, right? It's the shared angle. Of course it should be A. B on the big triangle is this angle, right? It's the leftover. It's not the right, it's not the orange. So it's going to go with D on the small triangle. Jenny, you with me on that?
Yeah.
C on the big triangle is the right angle. On the small triangle, what's the right angle? E. That's right. So those two triangles are similar. Now that they're similar, we know their parts should be similar, right? That's what CSP is, Schlaffer. Once they're similar, we can say their parts are. So we're going to say by CSP, I know that AB should go with AD, right? What's BC going to go with?
B.
DE. Don't forget your equal signs, right?
Could you just say by definition?
And AC should go with what? First and third. AE. AE. Cool. So all those should be related. So what that's saying is that AB, this big part right here, should relate to AD on the other triangle, right? And so on and so forth. Are they related by half, quarter, a fifth? I don't know. But they're all related by the same thing. So if one of them is a quarter, all of them are a quarter. Whatever, right? So now we know about the parts. Which ones do we actually care about? AD and BC, AB and DE. So we really don't care about this last guy again, right?
Oh, weird question.
Go.
Kind of weird. Like, in the future, is there a way to shorten it? Like, to just say, since it's double angles, the parts have to be similar, and then you don't have to explain CCP.
You have to prove they're similar, and then you can use CSP.
Yeah,
You can just do those two.
you don't have to explain.
But you have to have all the information down. If you can say that they're similar, then yeah, you can go right into CSP. But first you have to prove that, right? So, all the sides match up. I only care about these ones. What do I do to move those things around to get them? Multiply, right? So I'm going to get AB times DE equals BC times AD. Now we have a problem. We've got what we want except what? These need to be flipped, don't they? Now why am I allowed to flip an equation like that? Am I? Yeah, isn't 5 plus 1 the same thing as 6? But sorry, 5 plus 1 equals 6. The same thing as 6 equals 5 plus 1?
Yes.
Right? So we can flip them. When I do that, I'm going to rearrange this too. So I'm going to write AD first, and then BC. And then I'm going to move that over and write AB times DE. You don't need to explain that. Yep, we're allowed to do that. It's called reflexive property, also commutative, because we move the individual stuff around, but we're not going to do that.
You got me, right, you got me advanced since last part, so just the part right before you rearrange.
So here, here.
I don't, yeah, I get that in the next step.
AB and AD go together, right? You're good with that?
Yeah, I
Okay.
get that.
So what I did is I focused on these ones because those are the ones that I'm interested in, right? I didn't care about this. And what I did is I multiplied DE to this side, so I have AB and DE multiplied, and I multiplied AD to that side.
So that does explain what you did.
Yep. You don't need to give a reason. That's just doing algebra, okay? It's technically multiplication property of equality. You're allowed to multiply both sides if it's an equal sign, right? How do you feel about 3? Good. Let's look at 4.
Saying that
Where's like the really, really long
BC
one?
are congruent. Does that mean they have 2 sides?
Are we talking about 3 still?
No, I'm talking about 4.
No, it doesn't say that they're congruent.
I would-
Wait, AC and BC?
Yeah.
Yes, it does, yeah.
Okay.
So it says AC and BC are the same side length, right? So they're congruent. Alarm bell should be going off as soon as I do that. ED, that symbol right there, after it. I know, calm down. That symbol right there is not related to the words ED. It is the perpendicular symbol. Perpendicular means what?
It's intersect.
They intersect at what?
90.
90. So ED hits AC at 90. So we get this and this. I'll color one in so you can see the other. Right? We also got EF and BC being perpendicular. So here's EF and BC. This must be perpendicular as well. Right? So we have two 90-degree angles there. Now, which triangles do we care about? Because we have 3 in this diagram. The big one, the little one, and the even smaller one. So let's look what they want. AD belongs to this triangle and this triangle only, right? So this one's definitely coming to the party, right? BF only belongs to this one. So it's probably these two. AE, again, only belongs to that. BE only belongs to that. Yeah, so we're talking about these two. Those are the two I want to get similar, right? Those two. Well, luckily, this guy's already got a right angle, and this guy's already got a right angle. So we just need one other angle to get it done. How can we do it?
Vertical. No, you can't.
Well, the whole thing's an isosceles triangle. Remember, if the isosceles triangle, right, the angles will be congruent as well. So see how this side across from that is this angle?
You get the parts.
This side, this angle.
Yeah.
So the whole thing, ABC, this big triangle, ignore the stuff on the inside,
Oh,
is isosceles. So A and B would be the same. Okay? Yep. Yep.
So the intersecting lines means that it's 90 degrees, right?
This right here means perpendicular, which means hits at 90. Yep. Right? That symbol there told me they were 90. Not because they randomly intersect. So I'll get to that in just a second.
And that is,
So right here, Caleb, that symbol, this symbol, means perpendicular. Perpendicular means it's the opposite of parallel pretty much. It means they hit like a T, right?
So EB is perpendicular to AC. Okay.
Yeah, yeah. It's not just that they intersect, right? Because ED intersects AB, right? And that's not 90. If they told us it was, we'd have to believe them, but they didn't, right? That's what perpendicular means. All right, so these two angles are congruent, and I can call them A and B because I don't need the full name. You can call them DAE if you want, or CAE, or CAB. I don't care. Do we have enough information to prove these two triangles similar? Schloffer, what are we going to use to prove those two triangles similar?
corresponding.
Nope.
No. Angle.
Double angle, right?
Yeah. Right angle and the bottom.
Yep, blue and a right angle for both. So the triangle on the left is triangle ADE. And we're going to say it's similar to the triangle on the right side. Now look, angle A is blue in the left side triangle. What's the blue angle on the right side? B. D is the right angle on the left side. What's the right angle on the right side? F. What's your profanity? E is the leftover angle. So it must go with E on the other one as well, right? Turns out those will both be congruent by CSP, right? But we don't care about that. What we care about are the sides. So let's get it done. Now that the triangles are similar, we can use CSP. So by CSP. Now, I could write down AD and BF go together, and DE and FE go together, and AE and BE go together, but which ones do I actually care about? Again, if you want to write them all down, go for it.
AD.
I care about AD
BF.
and BF, so I'm going to write that one down. Don't they go together first and second, right?
Of course.
Don't forget your equal sign. I also care about AE and BE. Does AE go with BE? Yes. Now be careful. When you write these down, if you start with AD and AE, right, on the top, right, that's coming from here. So AD and AE are both from the left side triangle, so I wrote them both on top. If you're one of those people that likes to write the left side triangle on the bottom, great, good for you. But make sure you're consistent, okay? Left side guys go on top, right side guys go on the bottom, or vice versa. Whatever you're going to do, just be consistent, okay? So here we are, and we're done.
Why, okay.
Back up over.
I told you, what I should do at the beginning of every new thing is I should have an envelope, and I write in it a secret message, and I say, in 2 weeks, we're going to open this up. And at the end of the 2 weeks, I'll open it up, and you'll be like,
Five's the shit.
you'll learn it in 2 weeks. Oh my God, today's the day. I don't know. And if you're still struggling, that's okay. Come see me, I can help you out.
Here's where shit starts hitting things.
But this is where it starts coming together, I think. Right?
This one?
5.
Or the time we're at? Is this not?
Tells you AC and BC are congruent. Alarm bells.
Ding, ding, ding. Triangle theorem.
Right.
CD. What does that symbol mean?
Perpendicular.
Which means hits at 90, so CD hits AB at 90 degrees. So we got two 90-degree angles here. I like coloring in one so you can see the other.
Marv.
FE and AC are perpendicular. FE and AC. Gentlemen, are we capable of paying attention in between problems?
Yeah,
Because I don't think you've ever proven that. That's not a problem,
it is.
but it does concern me. I don't think you've ever gone 2 problems without like completely losing your focus. Just pointing that out. All right, so these 2 are perpendicular. Great. Which triangles we care about? We got Triangle City here. We got 1, 2, 3, 4, 5, 6 triangles. Could I prove them all similar? Probably not, but maybe some of them, right? Which ones do I actually care about? Well, if you look, AC is this segment, or AE is this segment, right? AE belongs to only one triangle. Yeah, it's part of this guy too, but like itself is only part of one triangle. The triangle that's laying down, right? So guarantee, it might be 7.
We're looking at that big one.
Guaranteed we're looking at this guy, right? Again, we can confirm we want AF as well. Definitely want that one. We also want AC. Now, look at AC. AC is this whole side here, right? Now that belongs to 2 triangles. This one and the whole thing. But we also want to know about AD. And what does AD only belong to? Triangle what?
ACD.
ACD. So we definitely want these 2. So we have a yellow triangle and a peach triangle. Those are the 2 we want to get similar. Make sense? Could we get the rest? Sure, right? Probably this one's just as good as that one.
Maybe that's.
But those are the 2 we need, okay? So here we go. In my laying down triangle, in the peach triangle, ignore this. That's not part of my triangle, right? Here's my triangle. I have a right angle. So I got one angle down. Yellow triangle, ignore this. That's not part of my yellow triangle. I have a right angle. So if I get one more angle, Lainey, what do you see? They share it, don't they? See how they overlap perfectly? Now, could you have done Isosceles triangle theorem and gotten that one and that one? Yeah, it'd still get you this. That's fine. But you don't need that.
Ask if we could do that, but I was afraid.
You can do Isosceles triangle or the shared angle. Either way works.
Shared angle probably easier.
I think so. If you see it, right? By shared angle, angle A is congruent to angle A. Now again, there are a lot of shared angles in this diagram. Which one do I care about? That one, because it pertains to both my triangles, right? Right? Don't just go writing down every vertical angles you see, right? Or linear pair. Not everything will be helpful, but it will be true. All right, so these 2 angles are shared. So now we have a blue angle and a right angle, a blue angle and a right angle. So how are these triangles similar? Schlaffer.
Angle.
Yep. It's the one we're going to use the most. So let's do yellow triangle first. I'm going to call that triangle ACD. And it's similar to the other triangle. Now, A in the yellow triangle, again, just so you're clear, we are talking about the yellow triangle here. A in the yellow triangle is a blue angle. What's the blue angle in the peach triangle? Also A, because they share it, right? C in the yellow triangle is the leftover angle, right? It's not the blue, it's not the right, it's the other. So it's going to go with F. D in the yellow triangle is the right angle. What's the right angle in the peach triangle? Careful. Peach triangle, it's E. Those aren't part of that triangle, right? I know, that's why I didn't cover it up. There's a reason for everything I do. All right, so you've seen the light, we got it? Awesome. Now, we want to talk about their parts. So we need to use what? CSP.
Yeah.
Remember, we can't do that until we prove they're similar. But now that they're similar, we can say by corresponding similar parts, we know that AC should go with AF, CD should go with FE, AD should go with AE. Okay, great. But which ones do I care about? I care about AE and AF. AE and AC. AE and AC. Oh, those don't go together. Oh, man. What about AF and AD? Oh, man, those don't go together. Well, it's not represented by division. That's why. That's the catch. So AE, what does it go with? AD. Did we want AE and AD? We did. Right? Again, it's not shown as division, which is why they're not like lined up together. Does that make sense? Right? They've already been separated. So if we want AE and we want AD, they do go together. So I'm going to write that. I'm going to do AD first because I always do the left triangle on top. AD, AE. Don't forget your equal sign. So we wanted these two. We also want AC and AF. AC is first and second. AF is first and second, so we can do that. Could you have written all of them out and then just taken what you wanted? Yeah, it probably would have been easier. Trying to match things up, right? You could have just written all of them out. We could have also said that CD and FE go together.
Is this here where we can move stuff around?
Yeah, by multiplication. So I'm going to move AF over by multiplication, right? And I'm going to move AE over by multiplication. Is everybody getting the hang of that?
Yeah, I like that.
Right. You know why they go away and they cancel, right? Because AF divided by AF is 1, right? We move the other thing over. Now, we're not done because they wanted it in this specific order.
So switch it to
So switch it. Can we make sure you switch? Right? Okay, cool. Moving on. 6. Number 7, only first hour got to. So if you want to know how to do it, you're probably going to have to watch that. First hour is my least talkative class.
I already see a shared angle.
So I should go there and make it longer.
All right, D is the midpoint of AC. So midpoint means it cuts that segment in half. Here's AC, right? D cuts it in half, so those two pieces are equal. You with me? E is the midpoint of AB. So here's AB. There's E. It cuts it in half. Right? Nope, it's not, because the reds and the blues might not be the same. Right? Maybe that's 3 and this whole thing's 6. Maybe that's 4 and the whole thing's 8. Right? They're half of each other, but we don't know across, right? So we want to get BC and DE together and know that they relate by double, right? That's what this means. So notice we want BC and DE together. So these two sides we're going to relate. They belong to the big triangle and the small triangle. And they will be. Yep. We'll be able to prove that. That's what we're going to prove. And this will be twice as big as that. That's what we're going to prove. So here we go. You see a shared angle. The small triangle and the big triangle both share angle A, right?
Could you also use B? No, okay, it's not small. So,
Cool. Now, we haven't talked about the sides, so we can't use the sides yet, but we're going to talk about them. AD, isn't it half of the big triangle side, AC? So AD and AC are related. Let's talk about that. You don't need to prove this. This is just from the diagram.
how do you know?
Well, this and this is the same, right? So if that's 3, then the whole thing, that's got to be 3, so the whole thing's 6. So 3 and 6, right? Or 4 and 8. Or 5 and 10, right? So they're related somehow. And notice they're related the same way over here. If that's 3, then this would be 6. If that's 2, that would be 4, right? They're related by half. So AD over AC will relate the same way that AE from the small triangle relate to the big side, AB. I did small side on top, big side on the bottom. Just be consistent, okay? We're going to have to flip it, but that's okay. So Schlaffer, if this was 3,
Yeah,
and the whole thing was 6, right? Has to be.
the other one would be 3.
What's 3 over 6?
1/2.
Good. If it was 4 and the whole thing was 8,
1/2.
see how they're all half? No matter what they are, they're going to be a half.
What is,
They're related by half.
it doesn't tell you though that, it's not a given that that is, no?
It is because we know that is the same as that.
Oh,
So this will always be half of the whole thing, right? That's 1 red, this is 2 reds, so it's always related by half, right? Both sides are related by half. If this was the third of this side, like we had like 3 of these over here, right? Then that would be related by a third, and this would be related by half. They would not be proportional, right? And then we couldn't do SAS. But because they're both halves, right? Or if they're both thirds or both fourths, right? Then we can. And we know it's a half because it's 1 versus 2, right? Now, if I had flipped these and gone big to small, I could have done 2 over 1, which is what we're going to end up doing, right? We're going to flip these.
Did you say that D corresponds to C right now? Or
The angles, they will, but we first have to prove the triangle's similar. So notice I have 2 proportional sides and an angle in between. side, angle, side, similarity. You with me? You have to talk about the sides before you can say that, okay? So we have two sides and an angle in between. Two sides and an angle in between.
So I have a quick question.
Yep, go.
So if I turn my paper over like this and it looked like that, would that be a different way of doing it?
No, it'd be the exact same thing, right?
Okay. I saw it right away as if it was flipped. And that would work.
We did it with all three connected, and we proved it for all of them. Yep. Good question. So by side angle side similarity, let's do big triangle first. That's ABC, right? I try to keep it alphabetical when I can. Must be similar to the small triangle. Now, angle A on the big triangle is purple. What's the purple angle on the small triangle?
A.
They share it, right? B on the big triangle is unknown. Oh crap, we have two unknown angles.
Okay.
But notice B on the big triangle is made up of the unknown side and the blue side, right? What's unknown in blue on here? E. Unknown in blue. That makes up angle E. Unknown in blue makes up angle B. So E and B are going to go together, so E goes next. C is made up of the red and the unknown, right? So if I go red and unknown here, it's D. Now we care about their sides. So let's write them all out by CSP. AB and AD should go together, right? Because they're first and second, right? Now if you notice, didn't we already talk about whoops. We haven't talked about AB and AE. But they go together, right? Right? And that's what we're interested in. Ooh, wait, what happened here? Why? A, B, C, A, E, D. We are good. Why did? Whoa, it's blue. We did blue before. That's why I'm confused. Sorry, it's just flipped, right? We also know that BC and ED go together. We have not talked about that before, but they're going to go together. So I'm going to write that like this. And then lastly, AC and AD go together.
Does that matter for this problem?
It will. Let's check it out. Now I flipped these. See how AD and AC is like this, and now they're not like that?
Yeah.
So I flipped it. So if I flip this, what is it going to be equal to? Nope. If I flip it, what's it going to be equal to? 2 over 1, right? So if that's equal to 2 over 1, and that's equal to 2 over 1, and they equal the green part, what must the green part equal? 2 over 1. They all equal 2 over 1. So therefore, BC over ED equals 2. Now we're not done because we didn't do the parallel part yet, but I'll stop here. Does everybody see how I got those letters together?
Yeah. And you just put blue.
And I noticed that that's the same as this, just flipped, right? So I flipped that, and it's 2 over 1. That's the same as this, but flipped. So that's going to be 2 over 1. Well, if they both equal 2 over 1, and they equal this guy must equal 2 over 1. Or 2, right? Are we okay with that? Are we okay with that? It's a little weird, but we're okay. Katie, you with me? Okay, cool. All right, next thing. Prove them parallel. Because the triangles are similar. Remember, triangles have proportional sides if they're similar, right? If they're similar, well, their angles will be congruent, right? So we can match up their angles using CSP. So I'm going to use CSP again, by CSP. What angles will go together? Well, I know that angle ABC and angle AED will go together because that's first, second, third, right? ABC and AED should go together, right? That's what it says here. ABC and AED go together, right? Because they're first, second, third. Also, angle ADE, that's first, third, second, should go with first, third, second over here. ACB, ACB. So these angles are congruent as well. Now, I only need one for my purposes. I'm going to go with the bottom one. That's ABC and AED. See how they're all in the same order? So those angles should be the same. It's the same thing as the sides. So by CSP, angle ABC should be congruent to angle AED. It's convenient when they're the perfect order, right? 1, 2, 3. But 3, 2, 1 or 2, 3, 1 also works. So if they're congruent, I'm going to color those in. That's this angle and this angle. Check it out. You guys with me on that so far? How I got those letters and knew they had to match up by CSP? So, we learned earlier in the year that if I have two parallel lines, then what's true about the corresponding angles? They're going to be congruent. So if these angles correspond, and they do, they're both top left, right? Then they'll be congruent. Corresponding angles, converse is also true. Meaning that if I know the angles are congruent, the corresponding angles, then what do I know about the lines? They must be parallel. So do you see any corresponding angles here?
Yes.
We do, right? So this must be the transversal, and these must be the parallels.
So I flipped it and I did a good job.
So by cap converse, these are parallel. You see it? Normally it's if the angles are parallel, or if the lines are parallel, then the corresponding angles will be congruent, right? Cap converse says if the angles are congruent, then the lines are parallel. Not just any angles, but the corresponding ones, right?
When did you get
These two angles,
yeah.
and I got it from CSP. ABC, AED. I could have also gotten angle CAB and DAE, but I chose those two because they were easy to get.
You guys wrote that?
What do you mean?
Well, you already got there, so you have to do another CSP.
For all the other angles? Oh, you could have written CSP just once. That's okay. Right? And just had it all be included. That's fine. I did it twice. So those angles are the same. So now we're going to say by cap converse, right? That's what got us the parallel lines. By cap converse, DE must be parallel to BC. Now they want it the other way around, so I'll write it like this. But same thing. Okay? Are you okay? Drinking's hard. How do we feel about that last bit? I think that's the most confusing bit, the angle thing, but you're going to be okay. 7 we're not going to have time for, but I am going to talk about it really quickly. I'm not going to run through it. I'm just going to tell you what you need to do. They give you this. What we're going to do is prove the small similar to the medium similar to the large, and the large similar to the small. We'll match up their parts using CSP, right, their sides. Then we'll switch out their sides for their little letters. See how AC is the same thing as B? See how AC is the same thing as little b? So when I have all those divisions, right, I'll switch out AC for B. And what will happen is you'll get something with a fraction, right? We'll have something like this. And you'll move the b's around. And you'll know what b squared is now. Same thing will happen with A when you switch out the parts. You'll do multiplication, and you'll get A squared equals something. It should be like C times E and like C times F. That means A squared plus B squared equals C times F plus C times E, which means F plus E, right? And what is F plus E? It's C, right? C squared. Guaranteed. Watch first hour stream if you want to see it. Or watch the thing we did when we did the worksheet.
Can I have a pass for
Yeah, or see me after school or before school.
Can I tell you about the time I saw 3 bears
Yes.
in an elevator in Madison? Wait, what?
Are you in the same homeroom?
No.
Okay. Rosie, did G1...
I'll tell you.
during- Yes, please. Did you need to pass, Lorelei, or no?
No.
Okay. You need
I
to pass.
do like passes.
I missed you.
What?
You were gone. I missed you.
Are these cupcakes still up?
Yeah.
Sure. See you later. Quiz tomorrow. 2 weeks on the dot. I told them 2 weeks ago. The stuff we're doing now is going to seem impossible. But 2 weeks from now, you'll be able to do it. And guess what today is? 2 weeks.
These guys are good.